Algebra 2, Concept 7A, Graph quadratic functions in standard form. In this concept, we'll continue graphing quadratics like we did in Concept 6, but this time we're going to graph them in a different equation form. So let's get some vocabulary definitions and formulas down. So the form we're going to be working in is called a standard form, and a quadratic function in standard form looks like this: y equals ax squared plus bx plus c. And that is where a, b, and c are constants, are numbers. Another thing with a quadratic in standard form is that we can always find the point to graph for a parabola at 0, c. And so that is the y-intercept. And sometimes you will use that as an extra point when graphing. I won't always do that in the notes. So again, vertex is either our highest or our maximum point of a quadratic in the parabola, or it is a lowest or a minimum point of the parabola. And then another characteristic of our quadratic graph is the axis of symmetry, and that is a line that divides a parabola into mirror images. Now, in our standard form of an equation of a parabola, here is the formula that you can use to find the axis of symmetry. It is x equals the opposite or negative of the b value divided by 2 times a. Here are the steps to graph a quadratic in standard form. The first thing you want to do is look at the equation and anticipate any transformations from the parent function, and you'll be able to anticipate a few. Step 1, find the axis of symmetry. So pick out your a, b, and c values and then plug it into our little equation that y equals the opposite or negative of the b value divided by 2 times a. Simplify that and then put it in the form of x equals whatever that number axis of symmetry value is. Step 2, find the vertex, x and y. So the x value of the vertex is simply the number of the axis of symmetry. And then to find the y value, you're going to plug that x value into the equation. Step 3, if you need to, use the extra point of the y-intercept. Again, I won't always do this in the notes. So this is just an extra point if it's needed, and it would be the point 0, whatever the c value is. Step 4, make a t-chart, and from the vertex, plug in 2 x values in the negative direction and 2 in the positive direction. So let's go ahead and graph example 1. We have the equation f of x equals 3x squared minus 6x plus 1. So let's start by picking out our a, b, and our c values. So our a value is in front of our x squared term, and that is 3. Our b value is in front of our x term, and we take the negative, so it's negative 6. Our c value is positive 1. Now, skip down to where it says AOS. That stands for axis of symmetry. Let's plug in our a and b values into our formula for the axis of symmetry to find that. So we have x equals the opposite of negative 6, which is positive 6, divided by 2 times 3. So that'll be 6 divided by 6, which simplifies to 1. So the equation of our axis of symmetry is x equals 1. Now let's find the vertex. So we've already found half of it, the x value. Now take the x value and plug it into the equation. So y equals 3 times 1 squared minus 6 times 1 plus 1. You can plug that into your calculator just as you see it. And you'll find that y will equal negative 2. So now we know our vertex point, which is the point 1, negative 2. Now we'll start from that point and we're going to put it in the middle of our xy table. And then we're going to put x values above that are 2 steps working down in the negative direction, so down to 0, negative 1, and then 2 steps in the positive direction up to 2 and 3. Let's start with negative 1, and let's plug that into our equation for x and find our y value. So our y value will be 10, and we'll put that in our table. Then we'll do that for each of our x values. So when you plug in 0 into the equation and simplify, you will find that y equals 1. Now, if you remember from graphing concept 6, that our other y values will be mirror images. So if you plug in 2 to the equation, you will also get 1. And if you plug in 3, you will get 10. Now, sketch your xy axis, label it, and label a scale. Carefully place your points. So we'll start with the point -110, 0, 1, 1, -2, 2, 1, and 3, 10. And then draw a smooth U-shaped curve through your points. Once you have that, go ahead and sketch a dashed line through the axis of symmetry, just to show that as part of the graph. Now let's talk about the domain and range. So with a quadratic, all x values are used, so our domain will be all real numbers, and you can use that symbol. Now to find the range, you're going to first look and see if the graph opens up or down. Our graph opens up. So it's going to be using the y values that start at the y value of the vertex and then all the ones that are greater than. So the y value of our vertex is -2. So our range is all the y values that are greater than or equal to -2. And since our graph opens up, we have a minimum point. We have a low point. So we'll just go ahead and say that we have a minimum point. And if we needed to name it, we would use that y value of -2. All right, let's try another example. So first thing is, if you're in standard form, pick out your a, b, and c values. So a is -2, b is -8, and c is +1. Now jump down to your axis of symmetry, and let's put our a and b values into our formula for that. So x will equal the opposite of -8, which is +8, divided by 2 times -2. That's 8 divided by -4, or -2. So our equation of our axis of symmetry is x equals -2. Now let's take that value and let's plug it into our equation for x. You can plug that into your calculator just as you see it. And when you simplify, our f of x, or y value, will be 9. So now we know our vertex point, which is -2, 9. So let's place that in the middle of our table. And then with our x values above our -2, we're going to place 2 more, stepping down in the negative direction, so -3, -4. And then below we'll go in the positive direction. And then take -4 and plug it into your equation for x. Make sure on your calculator that you put that value in parentheses. You'll find that you get 1, and when you plug in -3, you will get 7, and then we have the symmetrical values of 7 and 1. So now go ahead and draw your xy axis, label it, and label a scale, and then carefully plot those points at -4, 1, -3, 7, -2, 9, -1, 7, and 0, 1. You'll notice that the points now look in a downward shape U, and if you looked at the a value, it's negative, and so our graph is opening down. It is reflected. So draw a smooth U-shaped curve through those points, and then go ahead and sketch in your axis of symmetry. Now let's move over and identify the domain and range. So our domain, which is the x values that are used to create this parabola, will be all of them, so all real numbers. Our range starts at the y value of the vertex, which is 9, and since our graph is opening down, the graph uses all the y values that are less than 9. And since that vertex is on the top of our parabola, we have a maximum. And if we had to name that point, we would say our maximum is where y is 9. Now let's find a minimum or maximum without graphing. Because the vertex is the highest or the lowest point on a parabola, that y-coordinate is our minimum or maximum. So it says find the minimum or the maximum of the value in this quadratic, and then we'll give the domain and range. So the first thing we want to do is find the vertex. So let's pick out a, b, and c. So a is 1/2, b is -2, and c is -1. Now let's plug that into our formula for the axis of symmetry. So x will equal the opposite of -2, which is +2, divided by 2 times 1/2, which is 2 divided by 1, or 2. So our axis of symmetry, or the x value of the vertex, is 2. So to find the y value of the vertex, let's plug in 2 into our equation. So when we do the math, we'll find that y equals -3. So our vertex is 2, -3. Now we can know how the graph opens by looking at the a value, and I'm going to circle it. So it's +1/2. That means our graph opens up, and so our vertex is our lowest point. So it's a minimum, and to name that minimum point, we say that y equals -3. So a minimum of y equals -3. Now let's identify our domain and range. So our domain is all real numbers, and since we're opening up, our range is all the y values that are greater than or equal to -3. Example 4, let's look at a quadratic in real life. So this graph shows the average units of electricity used in homes compared to the temperature, and it's in Celsius. So if you look at this, is the graph of this function linear or quadratic? Which one is a better model? Well, since it is a U-shaped graph rather than a straight line, a quadratic is a better model. And so if it is quadratic, we're going to tell whether the coefficient of x squared in our equation, so that would be our a value, would be positive or negative. Since our U shape is opening up, then it would be positive. So our a value would be positive. Now it's time for the independent practice. So do these problems on your own. Pause the video after I stop talking. Do the problems on your own, and then come back and check your work. All right, welcome back. Well, you should have picked out the a, b, and c value of 1, 2, and -1, and then found that your axis of symmetry, if we use our formula, is -1. And then we'll take -1 and plug it into the equation to find the y value of the vertex, which is -2. So the vertex is at -1, -2. You should have placed that in the middle of your table, and then values in the negative and the positive direction, and then found that your values reflect the ones that you see in the video. This is a graph that's going to open up because our a value is positive. So we'll draw a smooth U-shaped curve. Make sure that you have sketched in the axis of symmetry. Your domain will be all real numbers. Your range, since it's opening up, will be the y values that are greater than or equal to -2, and you have a minimum. For number 2, you should have identified that you would have a minimum because the a value is positive, so the parabola opens up. You would identify your a, b, and c values, pick them out of the equation, and then find the x value of the vertex, which is also your axis of symmetry. Plug that in to find the y value of the vertex. So we're plugging in -2 into the equation, and your y value is -19. So we have the vertex -2, -19. Since our graph is opening up, this is a minimum point, and our minimum value would be y equals -19. Our domain will be all real numbers again, and since the graph is opening up, our range is all the y values that are greater than or equal to -19. In this example, you should have found that a quadratic function would be the best to model because the points are in a U shape. And then since that U shape is opening down, the a value in front of the x squared would be negative. This concludes the 7A notes graphing in standard form.